All right, we're testing this screen capture method of doing a lecture on my smartboard so that everybody could see it. We're going to look at section 5.4 in my nice Blitzer textbook with the really cool hot pepper on it. Still haven't figured out why we have a hot pepper. All right, section 5.4. We've been looking at acute triangles, acute right triangles that have trigonometric functions associated with their sides. Now we're going to look at what happens when my radius of a circle, if I have my circle and I assign a radius of 1. I assign a radius of 1. I know that the definition of a radian, or the angle that this arc will sweep, is equal to my arc length divided by my radius. I could also rearrange that by multiplying both sides by radius, and I have now another way of expressing the same thing, which would be my arc length is equal to my angle times my radius. Now if I assume that radius is 1, then I simply have my arc length is equal to my angle measure, which gives us an interesting circle that we call the unit circle. What that means is no matter how far I sweep an angle, let's call this angle theta. No matter how far I sweep my angle, the arc length that it will sweep will be equal to theta, because my arc length and theta are equal when my radius is 1. So let's identify a new value. Let's call this, instead of theta or arc length, why don't we call that t? Let's just call this t. So now the angle and my arc length have the same value. So when my arc length is equal to theta, we can call them both t. That means that my central angle, and my arc length are the same. This is what we refer to as a unit circle. The unit circle is very useful for us in modeling circular motion or modeling repetitive motion, like a clock going around in a circle or something on a spring bouncing up and down. We use the sine, cosine, and other trigonometric functions to model that. So in a unit circle, we find that the x value of a point is equal to cosine of whatever my angle or my arc length is, and the y value is equal to my sine of that angle. What that means is, if I have a point P, it's identified by x and y, I can also express that as P cosine the angle and y sine the angle. So I can now express a point in terms of cosine and sine. This becomes useful for us when we're looking at identifying triangles where I have maybe the motion of an object or the initial speed, and it has some y direction and some x direction, and I use cosine and sine to figure out if this object is moving with an initial velocity of this on this vector, which we have not talked about vectors yet, then I can find out how quickly it's moving in the x direction or how quickly it's moving in the y direction. So if I know that my sine of my angle is my y value and my cosine is my x value, then from that I can continue on and determine the other 6 trigonometric functions. cosecant. Cosecant is the inverse, or it is 1 over y. But if y is 0, the cosecant would be undefined, so we can identify this as when y is not equal to 0. The secant, there should be a little t there, excuse me, 1 over x, where x is not equal to 0, and the cotangent, x over y, again when y is not equal to 0. Now you'll notice there should also be a caveat put on this tangent when x is not equal to 0. So I can now identify my 6 trigonometric functions in terms of x and y from a unit circle. Let's look at an example of how we might use this. So I'm given a unit circle, and this unit circle has a point identified of -1/2 for my x value and the square root of 3 over 2 for my y value. So I can start with the information that I know. I know that my y value is associated with the sine of my angle, which is my y value, which in this case is the square root of 3 over 2. My cosine value of the same unknown angle would be -1 over 2. If I know my y and my x values, the tangent is very simple. I can just place it y over x, which would be the square root of 3 over 2 all over -1 over 2. To simplify, I can either look at this as the division of fractions, which would be the multiplication of a reciprocal, which would be the negative square root of 3. Just going to rewrite so it's a little bit easier to keep in my table. So let's look at the cosecant. Cosecant is 1 over sine, or 1 over y, which would also be 2 over the square root of 3. If I wanted to rationalize the denominator, I could multiply top and bottom by square root of 3 and obtain 2 times the square root of 3 over 3. The secant would be the inverse, or the reciprocal of cosine, which would be still a negative 2 over 1. My cotangent would be best if I write it out completely, which would now be the x value 1/2 over the y value square root of 3 over 2. That can be simplified to a -1 square root over 3, rationalizing the denominator by multiplying by 1, and I choose a 1 value of square root of 3 over square root of 3, I would obtain negative square root of 3 over 3. Let's look at one more example where I have a bit of a special case, where I now am giving you the t value, or that central angle or arc length, and I give it to you in radians of pi over 2. Let's look at a unit circle. A unit circle of pi over 2 would be, pi is 180, so pi over 2 would be here, and I'm sweeping an arc length of t with a central angle of t, and that t is pi over 2. So the point that I'm considering is a point here, P. My x value, so the value in the x direction, is going to be directly on the y-axis, so that would be a value of 0, with a y value of 1. So I now can determine sine of pi over 2 is 1, which is my y value. Cosine pi over 2 is my x value, or 0. Tangent pi over 2 is going to be my y value divided by my x value, which in this case is 1 over 0. I cannot divide by 0, so that gives me an undefined value for tangent. So we could just say that it is undefined. Cosecant is 1 over y, 1 over y, which is still 1. The secant, 1 over x, which would be 1 over 0. And again, I see that I have an undefined value at that point. So I now have secant and tangent, which are both undefined. Cotangent of pi over 2 would be 0 over 1, which is the reciprocal of the tangent, which 0 divided by 1 is just 0. So I now have my sine is 1, cosine 0, tangent is undefined, cosecant is 1, secant is undefined, and cotangent is 0 for this point under those circumstances. So your assignment out of your textbook for this particular chapter is going to be on page 532. One through 16, all. And that's it.